the displacement, we would take the derivative of to find the velocity. Then we take the second derivative of our displacement to find acceleration. And you can see the various notation here. Okay? What we're doing here now that we have the integrals is we can now, starting with acceleration, move backwards and find, hey, what's a function for our velocity if that was our acceleration? And then given that, what's the function for displacement? Okay? So we are integrating to move back. All right? And that's really what this whole section is about. So we know a lot of the concept already. It's just going to be applying it kind of in reverse. Okay? Now, just taking a look at an example here. We have a function here that gives us our velocity. Okay? And here's this function that's defined for us. And right now we want to just kind of link it without actually having to do any integrals. We want to link these ideas together, okay? So let's think about this. Just looking at the graph, forget about finding any kind of position or distance or anything like that. Let's just think about the graph. If this is our velocity, all right, we started at 0 kilometers per hour. And then as time went on, evidently what was going on here?
You went faster.
Well, yeah, we were going faster. We were speeding up, which means our acceleration is positive. Okay? And then from here to here, our velocity was constant. So our acceleration equaled 0. Okay? And now we're slowing down. Okay? And then what are we doing right here?
Constant.
It's a constant and it equals 0. So we're just sitting there trying to remember what in the world we forgot. And then we find out that we did forget something and we're now going backwards. We're speeding up in a backwards direction here. Then we're just going at a constant, and then we're slowing down, or we are going back towards the positive direction here. Okay? There's our velocity. We were still going backwards, but we were slowing down. We were approaching wherever it was that this thing we forgot was located. Okay? So this might be, hey, we're driving to the store, and whoops, we missed our turn. So now we're sitting at the light trying to make a U-turn. We go back a little ways to get to the store, and now we finally arrived. Okay? That's kind of the situation here. Now, we kind of already mentioned here, but let's talk about the graph above the t-axis, this part here. What are we doing here? When our velocity is above the axis, okay. Okay, we have a positive velocity, and you're right, the area will also be positive, okay? But we have a positive velocity, which means we're moving forward, okay? This part here, below the axis, how are we moving?
Negative.
Yeah, we're moving in the negative direction. It's a negative velocity. You could think of it in terms of, we're moving backwards, back the way we came. Okay? Now, part B is kind of interesting here. It says, find the total distance traveled by the car.
So that'd be, you would just make the area under there positive, right?
Okay. B and C bring to light this concept of, are we talking about a net area or a total area? Remember talking about that?
Yeah.
And if it was total area, we didn't care which side of the axis it was on. It was the area between the axis and the function, all right? So which one of these is going to be a total area, and which one of these is going to be a net area?
Net is C, total is B.
There we go. This is our net area. This is our total area. Okay? So, when I'm looking at this, I've got two trapezoids here, so I need to find areas. So this is a good opportunity to practice our area of a trapezoid. From here to here is point 1. That's one base. From here to here is point 3. And the height of this trapezoid is 60. Okay? Remember what the area of a trapezoid is?
Wasn't it like,
1/2
base?
A times H.
Find triangles.
Okay.
Wasn't it
You
one
just
half?
bring
Find
the
the triangles.
Wasn't it 1/2
B times
base
H.
1 plus base 2 times the height?
Yeah. 1/2 base 1 plus base 2 times the height. In other words, the average of the bases times your height. So the average of point 1 and point 3 is
0.2.
point 2. So this area here is point 2 times 60. So that's going to be 1.2. Or I'm sorry, 12. Decimal point in the wrong spot. Okay? So that's what though? That's 12
Units.
units. So what are our units here for distance?
Oh, kilometers.
Kilometers, okay? So we went 12 kilometers in the positive direction. Here we weren't going anywhere. Here though, again we've got point 1, and here we have from point 7 to point 4 to point 7, we've got a base of point 3. Alright, so there our area is 0.2 times the height there is only 20. Okay? So here we have 4 kilometers in the negative direction. Okay? So now that we know that, what's the total distance our car traveled?
16 kilometers.
16 kilometers.
And then
What's the net distance?
8.
8, okay? 12 minus 4, we ended up 8 kilometers away from where we started. Okay? So, that's in concept. It's nice to start here just linking it to areas. We're not even going to have to worry about actually integrating anything. But this is the concept, and this is how you have to think about it. Okay? Now, here's our total distance traveled, and this is where we can see this. We had a change of direction here. Now, there was a gap where we weren't going anywhere, all right? But we had a change of direction, right? We had to figure out when it was 0, and since there was a change in direction, when we were finding total distance, we had to accommodate for the fact that there was going to be a negative. Total distance traveled, okay, we want to determine an interval. So here we have our sign diagrams coming back, all right? So if we have a velocity function, we need to figure out where the velocity equals 0 and see if there is a change of direction. Are we going from positive to negative or negative to positive? Every time we change direction, that's going to define a new break in the intervals that we're integrating over. Okay? So, Alright,
Thank you.
we'll stop there. Have a great day, have a great weekend.